Hello everyone. Today is 29th of July. In this video, I am going to speak about the new features which I have added to my Razorpay clone project. The first feature is I have added the transactions. Then the second thing, as if you know that in my previous video when I was trying to create a new this apna tokenize the card for that payment, but it was not been done due to the error was the customer creation. So in this video I have solved the that error as well. Then the next thing is today we are going to discuss the outbox pattern as well. Outbox pattern is a system design part which is actually really helpful for implementing the uh, means the problem. We will discuss the problem in the later part. We will first see the wait a second. We will first see the project transactional annotation. Okay, so we have basically added the transaction annotation where we means uh, where we want actually the function to be thread safe. We have also considered that if we go in the payment service. In this payment service, what I have done, I have added the transaction annotation, but also added the isolation level, repeatable read. So this is not enough over here as isolation level repeatable read. What happens when one if consider there are thousand thread accessing this function, what will happen? The first function, the first thread will come and it will have the access read as well as the write. But if then the 99 threads which are remaining will have access to the read only, but we want to restrict the read also. So for that purpose, what we have done, we have added the pessimistic locking over here. What we have done, in the find by id and merchant id for update, we have created a new function over here. Okay, this was our old function, find id and merchant id. So if we go in the order repo, we went to the order repository. This was the function. For here we have added the pessimistic write over here with the help of lock annotation, and we have added the query as well as per our need. Okay, so the pessimistic write gives us an advantage that consider there are two threads. Okay, one thread has entered and it has the access to read as well as the write, but the second thread and the threads which will come after that will actually wait till this thread is actually been means actually does it work. Then the next thread will be entered. So this is how uh, we could avoid the overwriting which could be done by a thread. So it needs to be thread safe as well. So for that I have added the transaction annotation wherever it is needed, added in the payment service implementation as well as the order service implementation. The transaction annotation need to be added, means transaction annotation could be added anywhere, but talking about the pessimistic locking, whenever there is a state change over there, it is really helpful to add that lock annotation. Over here also have added it, but Wait a second. See, I have added the translation annotation over here, but not added the isolation level, as we the requirement of each function might be different, so we need to see at as per our purpose and then act on it. Okay, then the next thing was the customer creation. So I will directly show you the means postman means by hitting the http request. So we have ran the, now first we will create the merchant. In the merchant I will hit the, we will first, okay, so the customer already, then I will only directly log in. Okay, I got the access token, then the API key is already there. I will create an order. Okay, here as you are able to see, I am passing the rate limit exceeded. Then I will do one thing, I will actually create new API, go over here. See, as you're able to see, I am passing the customer details over here. Okay, we have created the order over here. It's also giving us the customer ID. Now we will do one thing, we will actually tokenize. Okay, so this was the card info. I will do one thing, I will change its digit as I have already done it. Okay, so this is the card info. Now we need to tokenize it. Validation request. Okay, I think there's an issue, but we will move to the Outbox Kafka pattern. Actually, there is a problem. Consider there are two system. Okay, so when the DB saves the payment, Kafka need to send payment status updated event. But to solve this problem, actually what we are doing, we are creating a DB which consists of the Outbox event. Then what will happen if consider that the while the payment was going on, the transaction failed. Okay, then either it will be 100% success or fail. Okay, that's not the issue, but what we need to do, we need to run a scheduler which will run 200 millisecond. Then it will fetch all the pending event from the outbox table. Okay, it will actually fetch the pending event from the outbox table, then put them into the Kafka queue, mark the pending as success. Okay, that's what the scheduler will do. But over here problem is not solved. Okay, it might also fail, but problem is slightly reduced. We need to notify the merchant. Okay, we need to notify it, but we can do one thing. If the scheduler fails, we could provide some attempts for the retry. It will retry and try to fetch the update, but if it's not updated, we will eventually fail it. Okay, so that's what it is in the outbox pattern. I will show you the working of this later on then. So that's all for this video. Thank you.